comfortable, hacker. Stay a while.
In a previous video, we built our own voice-controlled AI assistant. In this video, we'll upgrade our AI assistant to make use of Google's text-to-speech API and get a better, more natural-sounding voice for our machine assistant. We'll take a look at how to set up access to this Google account and the API following these steps and the good documentation that Google have created. And then in the second half of the video, I'll show you the changes that can be made to the AI code so that this Google API is being used instead of the Python text-to-speech option we had to begin with. So let's take a look at some of the Google API documentation. I've taken these steps already, so I'm just going to recap what I did. If you go to cloud.google.com or Google how to set up a Google Cloud account, you should get something like this where you can start the process. And I want to highlight that right now you can get $300 worth of credits just by signing up, which run across 90 days, which should be quite a lot for these hobby projects and experimentation. There are also other APIs for text-to-speech where you send the text that needs to be turned into speech somewhere online and get a better, realistic sounding sound file out of it. But here we'll be using Google. So sign up. And once you've done that, you can find the cloud text-to-speech guidance. And all I did for this video is basically follow the instructions, and that was enough here in my Linux computer to get everything running. So you set up a project first in the Google Cloud Platform. You can name it My AI Assistant, for example. That's going to create a project ID, which we can refer to later. You can access the Google Cloud shell online in the Cloud Console, but what we'll be doing is accessing it from our computer and our command line instead. If I open my terminal, I can bring the commands here and run them there. But I've already done this. So this curl command downloads that archive file. I can see it's here, and then I can extract it into the Google-Cloud-SDK folder with the next command. So this tar-xf1. So all we're doing is following these commands step by step. Once that's been done, you can run the Google Cloud SDK install script. And once that's been done, it's been installed, can be accessed in later terminal sessions from anywhere. You can then initialize it by running Google Cloud SDK bin gcloud init. And that's going to take you through the initialization options, which you can do once you've set up the Google Cloud account. I think I can run it again for you. It's already been established for me, but I can go through the process here of reinitializing the configuration. Use my email account, the project that I created called Nomadic Line, and that initializes my gcloud locally. So now on my computer, I can run gcloud this way. So it's there. It gives me some API endpoints and instructions, I can pass it more detailed instructions later. So that's successful. We can enable the API next, step 3 in Google instructions, by then running gcloud services enable the text-to-speech API. There are a number of different APIs and services that Google provides, and they are not enabled by default, so we need to go through this step. But rushing on to the next part, we then need to be able to let the Google side know that we really have permission to make requests to this API as part of this project. So we need to establish some credentials. And again, we can just take the steps outlined here in the Google guidance and run them in our terminal one by one. We can export our project ID environment variable, and that's going to then fish it out from whatever the configuration value is for the project. So the project ID, this is going to use the gcloud client to fetch the project ID that we have for the project we created. We need to create a service account, which is something that belongs to the project and is what the Python client library needs to make text-to-speech API requests. So we run this next command. You can call it something else. And then we grant the service account the permission to use that service just by running this command. So again, we've already defined the project ID here, so we can just paste this and run it, and it's going to insert the project ID into the right place. And importantly then, we're going to create credentials that the Python will use to log in as this new service account that we've just created. We can save them down into a key.json file in your user folder with this command, the tilde, and then we need to set the Google application credentials environment variable. Take note of this command because we may need to re-enter that if we reset our terminal. So if our terminal session is wiped out, the environment variables may be wiped out too. And we will always need to make sure that the application has access to these credentials and knows where to find them so that the API calls succeed. So once again, we're just running these commands in our terminal. For example, here in Visual Studio Code to set us up with API access. And then before we get to play around in Python, we still need to install the client library. If I'm in my virtual environment, I just run pip install upgrade Google Cloud text-to-speech. And that's what I've done here as well already. And then we've got all we need. So to recap, we've created our Google account with our $300 of funding. We have enabled our API for text-to-speech. We've installed the gcloud client following the steps, authenticated our API, created those credentials, and then finally with this pip command, pip install upgrade Google Cloud text-to-speech Python, we've installed our client library. So now we can start actually making use of our API. Let's make sure, as I was saying, that I've got the credentials properly set and exported. So I'm just going to run this here. So now this environment variable has whatever the key.json file contains. And here I've created this helper file that's going to be in the repo called Google Voices. And this allows us to see and explore a bit what's available to us in the API. So let's take a look. I'm just going to walk you through this. There's a few functions here. We can list languages and list voices. So what are the different languages? It doesn't have to be English that the API provides. And for each language, there are multiple voices. So these are methods that list those out, and we'll see them in the terminal. when we run our Python. And then here is a way to generate that sound, that WAV file, from whatever text we pass through in a given voice, and then also save it down as a file so we can store it if we want. So let's run this. And see what happens.
Make yourself comfortable, hacker. Stay a while.
Okay, so that did a bunch of things. We got our list of languages at the top here from our first method, 53 languages provided with codes here, and then picking out English, 80 voices is what we get with local area, Australia, British, US, Indian, male or female type of voice, and then the frequency. So we can explore and experiment and pick. With our helper tool, we also heard it say our sample text, which you can find here on row 63. So this generates a speech, and we've set in the voice that we want. So in this case, EN US News-K. And then our text, make yourself comfortable, hacker, stay a while. Then we're actually using Pygame as our library to play the sound. Video games often need to play lots of sound and speech, so there's a handy little set of easy to use options in Pygame. And that's what we'll use in our AI 2. So we can explore, take a look, use this Google Voices Python file if you like to list out the possible voices and get them to speak for you, and pick out the voice for your AI that you most prefer. And then we can take a look at how we actually bring this on board for our AI. Let's shrink this a little bit. So what are we bringing in? Previously we used Python's text-to-speech X3. Now we're of course going to use the Google option. So what are we bringing in addition? We're bringing in the google.cloud.text-to-speech module. I'm naming it just TTS. Bringing in Pygame for that playing of the sound WAV file. Because what the API does is it takes your text and generates an audio file. Well, we need to do something with an audio file that depends on the use case for the API. In our case, we kind of want to play it immediately. Maybe you'll want to create a library of sounds and store them. That's up to you. We're also going to import, I think, time to be able to create some pauses and between different speech activities. I've also, just to note, added this section on muting certain kind of sound card errors that people were having with the AI. There are more warnings than errors. Of course, you want to solve errors rather than leave them to linger, but apparently many people get a lot of noise in the terminal for Python, including me and my virtual machine here when trying to run the PyTTS-X sound creation here. But let's skip onwards. So we've created a new method here from line 39 onwards, where we essentially do what was happening in Google Voices. We take a text, use the Google API that we now have access to, and generate some sound. We pass in the voice name, so that en-us, news, etc., and then the text we want to turn into noise and sound. It'll take the language code, it's going to take the text input and format it as synthesis input using an input method. We'll build the voice request, and there are certain parameters that could be set here. I'm doing it this way. There are other examples in the API documentation, and I'm saving it down as, or creating it as a WAV file, audio encoding linear 16. There are alternatives you can explore instead, MP3, for example, as an alternative. Once we've set up the configuration, we instantiate our client and then fetch our response here by running the synthesize speech command. We pass it in our text input, which is synthesis input, the voice parameters, and this audio configuration. That then sends away our text and this object to the API. So you do need to be connected to the internet, to be clear. And we get this audio object back, where we then return from this method the audio content of that response. So what we get out of here is this WAV file, basically, this audio content with a WAV header. So that's the kind of meaty bit of generating our sound. And I've also updated our standard speak method here. So what the AI assistant does whenever we ask it to speak. Previously, it was indeed using the TTS X3, and now we've just added a few rows. So we create a speech variable where we pass the Google text to WAV method our preferred voice. I've just hard-coded it here. We could set it up as a variable outside, and then whatever gets passed through the speak command as a text. So where does that get called? For example, if we are doing something like a Wikipedia query and returning it, then we will ask to speak. If we're opening a page, the AI will say opening. If we are querying Wikipedia, it will say querying the Universal Data Bank, and then actually speaking out whatever the query returns. So that we're using the speak command there a lot. Here, we take whatever that text is, run it through the method we just covered, get our WAV file, and then we need to play it. So we can initialize this mixer component of the Pygame library and adjust the frequency on the basis of how you want the voice to sound and what you're getting it as, what the model contains. We create the sound as a playable thing by marking it as a sound object of the mixer, and then we can play it right away. I've added a little sleeper method here to make sure there's enough time for it to play entirely, and each time I run this, I also quit the mixer that I've initialized, so sort of self-encapsulated method and doesn't leave any mixers running in the background, for example. Okay. With these things, we don't need to then change any of the existing code. We've just changed the mouthpiece, so we can continue with our logic of adding new methods and tools to our AI brain whenever we want to, but now instead we get a different sound. So to wrap this up, let's just explore and experiment what this might sound like.
All systems nominal.
Computer. Wikipedia, artificial intelligence.
Artificial intelligence, AI, is intelligence, perceiving, synthesizing, and inferring information, demonstrated by machines, as opposed to intelligence displayed by non-human animals and humans. Example tasks in which this is done include speech recognition, computer vision, translation between natural languages, as well as other mappings of inputs. AI applications include advanced web search engines, e.g., Google Search, recommendation systems, used by YouTube, Amazon, and Netflix, understanding human speech, such as Siri and Alexa, Self-driving cars, e.g., Waymo, automated decision-making and competing at the highest level in strategic game systems, such as chess and Go. As machines become increasingly capable, tasks considered to require intelligence are often removed from the definition of AI, a phenomenon known as the AI effect.
And there we have it. We've made our AI assistant slightly better once more. In a future video, we should be plugging in our AI assistant to a large language model and its mighty powers. For example, ChatGPT, which should be a big, fun upgrade to our growing virtual brain. Until then, be sure to take care, have a great time, and I'll see you soon.